Right. The Basic Education Department, Basic Education Republic of South Africa, Mathematics Paper 1, May, June 2023. Marks 150 and the time 3 hours. Right, we're going to look at the first question. And the first question is very straightforward, but we're practicing with it. So you need to write the notes after this, but obviously know very well that it's not going to be possible for you to write the notes during the during the lesson, but you write the notes after when you watch this video. I'm going to pause this video immediately afterwards. Right, the first question is x squared minus 7x plus 12. And we are actually going to look at how to get this question solved. Right, so to solve this question, it's something very, very straightforward. We start by using the method of factorization. So, right, so we write open parentheses like this. The factors of x squared are clearly x and x. The factors of 12 plus 12 are clearly minus 4, minus 3, x is 4, or x is 3. And these are the solutions to this, and the marks are 3. Okay, pretty straightforward. Next question. Right, in this case, we need to solve for this question. So to solve this question, we clearly expand. First, we use a method we call distribution. Right, so the distribution ensures that we can distribute. We can open up the brackets by multiplying by the x, so that we have 3x squared plus 5x. We transpose the 1, which becomes negative, and the result is then 0. The quadratic formula from which we can see that a is 3, our b is exactly 5, and our c is minus 1. X minus b plus or minus the square root of b squared minus 4ac out of 2a. Right, so it is minus into b. Right, so it is exactly the minus b there. I don't need parentheses around that. So I can just remove the parentheses from there. Right, so, and this gives us clearly minus 5. Okay, so it gives us clearly minus 5. Right, so we have minus 5. Right, plus or minus the square root. Right, the b squared is going to be 5 squared minus 4. The a is 3. In the c is minus 1. You put a close square root. And this is exactly twice a, and a is 3. Right, so we continue. Continuing, we have exactly minus 5 plus or minus. It is the square root of 37 under the square root. And we actually divide by 6. From which we're able to continue and find plus the square root of 37. We divide by 6. So x equals minus 5 minus the square root of 37 divided by 6. Okay. Right, so to 2 decimal places, this is approximately 0.18. So x equals minus 1.85 using the decimal point, but you could also use the decimal comma. I believe the screen is visible. Is that correct? Okay.
Yes.
All right, thank you. We continue and we look at the next one, and the next one is exactly 1.1.3. We are looking at the solving for x given a quadratic inequality. So this one here is a quadratic inequality. So we have x squared plus twice x. Right, so we have x squared plus twice x. Right. Transposing terms, we have actually x squared plus twice x. We transpose 15, and the result is negative. We factorize these two guys here, right, into a product of linear factors. The factors of x squared are clearly x times x. And there are two numbers whose product is minus 15, but whose sum is 2. And those numbers are minus 3 and plus 5. There are two things we call the critical values. The critical values. What are the critical values? The x equals 3 or x equals minus 5. So now it means, therefore, we look at the associated graph of this because the coefficient of x squared is 1. Therefore, it's going to have a minimum vertex minus 5 and then 3 x-axis. If this is negative, it focuses on the part of the graph that is below the x-axis, so we focus on this. So below the x-axis, we have that. So as a consequence, what are the solutions to this? We are describing the part of the graph that is less than 0. The negative part below the x-axis is actually minus 5 less than x less than 3. So that is what we are getting over there. And this becomes the solution. So between minus 5 and 3, the graph is below the x-axis, and therefore it is negative. Negative. Okay, next question. 1.1.4 is the next one. We focus on the radical equation. This one becomes an equation involving a radical. Right, the radical is the square root sign. What do we do with this one? We square both sides of the equation. 2 into 1 minus x. You square the left-hand side. You square the right-hand side. We have 2 into 1 minus x. You square this one is actually x squared minus 2x plus 1. Right, so we have this one, 2 by 1 is 2. 2 by minus x is minus 2x. X squared minus 2x plus 1. X squared, if you transpose the minus 2x, because they have the same sign, it's going to cancel. It's going to cancel. And then you have 1 minus 2, which is minus 1, and the result is 0. Right, if you have this, you can actually be able to solve this one. Is a difference of two squares. You can write it as 1 squared minus that. So the idea of the difference of two squares. Right, difference of two squares. And we also have the difference of two cubes. A squared minus b squared, these are two squares, and therefore the result is the same as a minus b, actually into a plus b. So these are the same thing. And hence the three lines, so they're equivalent. Right, so using the same analogy, we say the factors of the x squared minus 1 squared is exactly x minus 1 into x plus 1, and the result equals 0. This is x equals 1 or x equals minus 1. Okay, as usual, when dealing with the radicals, we need to always check our results and we need to check the answers. So let's do a quick check. Doing a quick check, we check the x equals 1. We check the left-hand side, and it is the square root of 2 into 1 minus x. Okay. 1 minus 1, 0. And the right. X minus 1, 1 minus 1, 0. And therefore, the left-hand side is equal to the right-hand side in the case of the x equals 1. But we're not done. We're also going to check the other roots. So we also check x equals minus 1. The left-hand side is the same as what? It is the same as the square root of 2 into 1 minus x, which is the square root of 2 into, okay, you put the minus 1, and therefore it's 1 minus. You have the minus 1 there, and you extend the square root like that. Okay, what is the meaning of all this? Now, negative times negative is positive. 1 plus 1 is 2. 2 times 2 is 4. So under the square root sign, we have the number 4 whose square root is plus 2. The right-hand side of the equation is actually x minus 1, and therefore you have minus 1, which is minus 2. But clearly the left-hand side is 2, the right is minus 2, and the conclusion, therefore, is that the left-hand side is equal to the right-hand, is not equal to the right-hand side, because one is 2 and the other one is minus 2. So x is not equal to that. So in other words, we say that x equals minus 1 is actually not a valid solution, not applicable, is not applicable. Don't want to say that. We also say that x equals minus 1 is an inadmissible solution. Inadmissible solution. Okay. And now we have solved this one and we are done. In passing, we can make mention of some very interesting rules like your the difference of two cubes. Right, so in particular, when you get to the calculus part, we shall meet cubic functions. So we can talk about the difference of two cubes. What is the difference of two cubes? And we can speak about the sum of two cubes. So we have a cubed minus b cubed. You cover the cubes, you have a minus b. You square the a, it becomes a squared plus ab plus b squared. And this is the result. Okay, moreover, we can speak about the sum of two cubes. What is the sum of two cubes? Watch the sign. If it's negative here, it becomes positive there. The sum of two cubes plus b cubed. Okay, you cover the cubes and you have a plus b. You square this one is a squared minus ab plus b squared. So that is the answer. Okay. Let's look at the next question as asked in this year's exam, June. Solve for x and y simultaneously. The simultaneous equations is something you need to know, but let's deal with this one and see how you can solve this simultaneous equation. But first things first, we consider the first equation. So first, we consider 3, which is 3. Okay, if this is the case, if the bases are the same, we equate to the exponents, which means x plus y is 3. Okay. Right, from which we can be able to make y the subject. If we make y the subject, it becomes minus x plus 3, and we can call this one equation 1. Right, so we also have this one, x squared plus y squared equals 17, and this one is actually equation 2. Right, so you put 1 into 2, which means that you have x squared, okay, plus 3. So this is x squared minus 6x plus 9 is 17. 2x squared minus 6x. If you transpose the 17 to the other side, it becomes negative, giving us exactly what? Minus 8 equals 0. Minus 8 equals 0. You can divide through both left and right by the highest common factor. The highest common factor is this point is 2. Dividing through by 2, you get x squared minus 3x minus 4 equals 0. The factors of x squared are x and x. The factors of minus 4 that give minus 3, or actually minus 4 and plus 1, giving us x equals 4 or x equals minus 1. Okay, but if y is minus x plus 3, it means therefore y is minus x plus 3, which is minus 4 plus 3. I'm using equation 1, and therefore the result is minus 1. Or y equals minus x plus 3 from equation 1, and therefore it's minus 1 plus 3, which equals 4. Okay, right, so now we have got these things. What are the solutions to this? Right, so in conclusion, we're able to say the following. Thus, it is true. Thus, we have that x is 4, y is minus 1, x is minus 1, y is 4. Okay. And therefore, we have solved these equations, 2 equations simultaneously. And we are excited because we're done. We continue to do the next one. Right. In June this year, they've asked this question and we analyze it together. We analyze this question together. Analyzing this question together, we have the following. We ask the question, what is the result of these? What is the result of this? So determine the third is of a calculator, the value of these series. This is a series because a series is just a summation, it's a sum, right? So a series is a sum, and therefore let's evaluate the sum here. So this is exactly the same here. So it's 1 divided by, you have the square root of 1 plus the square root of 2. You multiply these by the square root of 1 minus the square root of 2 divided by the square root of 1 minus the square root of 2. 1 over the square root of 2 plus the square root of 3. Okay, square root of 2 minus the square root of 3, right, which is the square root of 2 minus the square root of 3. Okay, so we do this. So we continue. So we have this one, which is minus the square root of 3. Next, we continue. We focus on this one right now, which is 1 over the square root of 3. So we saying we actually rationalize. The word rationalize is derived from the word rational. How do you rationalize? You rationalize normally the denominator so that we can understand the numbers. Right? If we have the square root of 2 plus the square root of 3, how do you rationalize this? To rationalize that, you have the square root of 2 plus the square root of 3, the square root of 2 minus the square root of 3, the square root of 2 minus the square root of 3, the square root of 2 minus the square root of 3, 2 minus 3. 2 minus 3 is minus 1, meaning you divide, and therefore the square root of 2 is going to be negative, the square root of 3 is going to be positive. You're dividing by minus 1. So that becomes the answer. But the answer can be written as the square root of 3 minus the square root of 2, starting with the positive number. We have rationalized over there, and it's very, very clear. So we're excited. Okay, because we know how to rationalize. We continue to rationalize. We look at this one. So we look at square root of 3. And to the square root of 3, we add the square root of 4. And we should rationalize. The square root of 3, which, so if you rationalize, you multiply by 1 because these things are the same. If you divide them, it's like 1. But the actually expression you multiply by must have the opposite of the middle sign, which is this one here. Square root of 3 here minus square root of 4. Plus dot 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 is 1 over, oops. Okay, so we have these. We continue. So you have the square root of 99. You add the square root of 100 to it. You multiply by the square root of 99 minus the square root of 100. You divide by the square root of 99 minus the square root of 100. Okay, so you have this. So if you multiply this one here, it's going to become what? It's going to become what? So if you multiply, so it's going to become the square root of 1 minus the square root of 2. So it becomes, if you multiply by the square root, it becomes 1 minus 2. Plus square root of 2 minus the square root of 3. Multiply, it becomes 2 minus 3. Square root of 3 minus square root of 4. You multiply, it becomes 3 minus 4. Okay. Okay. Okay, you continue. And therefore, now you have these. Square root of 99 minus the square root of 100. 99 minus 100. So 1 minus 2 is minus 1. Meaning when you divide by minus 1, the negative is going to become positive and the positive term is going to become negative. So this is also minus 1, meaning the negative term is going to become positive and the positive term is going to become negative. You have this one is 3 minus 4 is minus 1, meaning the square root of 4 is going to be positive and the square root of 3 is going to be negative. You must subtract this one here, which is minus 1, meaning you have the square root of 100 minus the square root of 99. So we continue. What is the result of all this? So now what we have, let's check. So we have a square root of 2 cancelling out. Square root of 3 cancelling out. Right, so let's look at what this means to us. Let's look at what this means to us. So what it means, a couple of things. If we have only two of these, would anything cancel? If we were to stop just at the pan, so the square root of 2 is going to cancel, so you're going to be left with the square root of 3 minus 1. Right, so in other words, you're just left with this one and the minus 1. So here, everything is going to cancel. So you're going to just be left with minus 1 plus the square root of 100, which is 10. And therefore, the result is 9. Okay, get this. So we continue and we look at the next question. Where we got 9 there. Right, question 2 is based on sequence and series. We have the geometric series, we have the convergent geometric series, we have the sum to infinity, we have the next two terms of the pattern, we have the odd terms, we have the P26 and the sigma notation as well of the summation. Right, so we continue to solve the question. Let's solve now 2.1.1. Given the geometric series, this one, is this a convergent geometric series? Justify your answer with the necessary calculations. We solve. Right, so in other words, given the geometric series, which is 1 over 5, 1 over 15 plus 1 over 45, we ask the simple question, is this convergent? Is this convergent or not? How do we know convergence? So for us to speak of convergence, we actually do what you call the constant ratio. How do we do the constant ratio? So the constant ratio is going to be T2 over T1. What is T2? Which is 1 over 15 divided by T1 is 1 over 5. Right, so if you have this, it's 1 out of 15. So you therefore look at this. You divide these by 1 over 5. Dividing by 1 out of 5, you multiply by 5 out of 1. And the result is 5 out of 15. 5 goes how many times into 15? 5 goes 3 times into 15, giving us the conclusion that, or leading us to conclude that the common ratio is only 1/3. Right, with that said, hence, thus we have that at the end of the day, the common ratio is always, it lies between -1 and 1, and therefore it lies between -1/3 and 1, like this. Okay, we happy? So because 1/3 is 0.3 and 0.3 recurring lies between -1 and 1, the conclusion therefore is that the series is convergent. The series is convergent for 2 marks. The next question. Given the geometric series, the same one, calculate the sum to infinity of this series. Right, so the couple of things that you already know. So the first term is 1 over 5, and we have seen that the common ratio is 1/3. The sum to infinity of the series is a divided by 1 minus r, which means the sum to infinity is a, which is 1 out of 5 divided by 1 out of 3. The sum to infinity is 1 to 5. So what is 1 minus 1/3? It is 2/3, which is 1 to 5 divided by 2 out of 3, which is 1 to 5, multiplied by 3 out of 2, which is 3 out of 10. So in other words, so the sum to infinity is 3/10. Is 3/10. So in other words, if we add all these terms and add the next one and add the next one up to infinity, the result is going to be 3 out of 10. Next question. Right, in June this year, it was written this year from the Department of Education, so it's a hint to the November exam. I must tell you that much. Right, an arithmetic and geometric sequence are combined to form the pattern. So at this point, this is very interesting. So we're combining, so in arithmetic with the geometric, they are combined. So we put two sequences together to form the pattern, which is given by this. So this is both arithmetic and geometric combined. You need to write down the next two terms of the pattern. So what are the next two terms of this pattern? Let's see. Let's study the pattern here. Right, so you have x. After x is 2. So 1x, then 2x, then 3x, then the next one must be 4x. Right, so this one is 1 over 3, and this one is 1 over 9. So 1 over 9 can be written as 1 over 3 squared. 1 over 3 cubed. So which means this one is going to be 1 over 3 to the 4th power. You can write as 1 over 81. So 1 over 81 is 1 over 3 to the 4th power. So write down the next two terms of the pattern. What are the next two terms of the pattern? So the next two terms are 4x, 1 out of 81. These are the next two terms of the pattern. Okay, we're excited, we're happy, and we move on to the next one. Right, so here we have an arithmetic and a geometric sequence are combined to form the pattern, which is given by that. Determine the general term for the odd terms of this pattern. Write down your answer in terms of x. So we have Tn. A plus n minus 1 times the common difference. So Tn equals the first term. But we're dealing with the odd ones. What are the odd ones? The odd ones are x, then there is 3, then there is 5, then there is 7. Instead of 8, you put 9. Instead of the next one should be 10, but you put 11 because you are choosing the odd ones. But the first term is x, and then you find the common difference, which is 3x minus x, which is 2x. So which means the first term is x plus n minus 1 into the common difference between the odd ones. Right, the common difference between the odd ones. Right. General term for the odd terms of this pattern, you write down your answer in terms of x. Right, right, right. Okay. Okay. Right, I want us to look at this question and think very, very carefully and ask ourselves what this question means. Right. What this question means. What are the odd terms of this pattern here? Right. General term for the odd terms of this pattern. Right. So depending on the case, you can do the question as follows. So one way to look at that is to consider the term x, then 2x, then 3x. Right. And the word ORed is used here. Right, let me explain something about the word ORed used here. Right, so the word ORed was used to signify something. What did the examiner mean by ORed? They meant those ones whose position is ORed. So in other words, this is T1, this is T2, this is T3, T4, T5, T6, T7, T8, T9. So the odd positions, will be X, T1, T3, T5, and so on. And the common difference between those is 2x minus x. It's, for instance, 2x minus x. 2x minus x is only x, so which means the common difference is going to be x. Right, so we continue. We continue. Okay, so as a result, we have the following. X plus xn minus that. X minus x, so the answer is xn. The answer is xn. Okay, and we're done. Right, so that was only for 2 marks. Right, let's look at the next question. Still, we have an arithmetic and a geometric sequence have been put together. They've been combined. Calculate the value of P26. Calculate the value of P26. P26. So now in this case, there is Px is this. Pn is that. Right, need to know that in the P26, it's going to become what? It's even. 26 is an even number. If it is true that 26 is even, it means that position 26, you have geometric. You have the geometric sequence term. So you'd have the geometric sequence term in position 26. So if that is true, it means you can use the term, the formula AR to the n minus 1, general term for the geometric. So which means, therefore, we have the following. So at TM26, P26, it's going to be 26 divided by 2 because it's both combined. So it's going to be half of these because half is arithmetic and then half would be geometric. So it's going to be position 13. Right, so it's going to be at position 13. In at position 13, it's going to be the first term of this. The first term of the geometric is 1/3. The common ratio is like T2 of the geometric T1, which is 1/9. We're dividing by 1/3, T2, T1, 1/9 times 3/1, 3/9, 1/3. 1/3. Okay, so it's 13 minus 1. Okay, goodness me, we continue. So we have T13. Um, so this is 13. So T13 is therefore that one. Okay, you can write it also as 1/1/3 to the power. So you can write 1 to the power 13 and then 13 there. So 1 to the power 13 is that, but 3 to the power 13 is 1 million. 1,594,000. 3, 323. You can write it in scientific notation. 6.27 times 10 to the minus 7. 3 to the minus 13. Hey, anyhow, the answer is just this one here. So in other words, term 13 is 1 out of 3 to the power 13. And you have this. You have this. You have this. Next. Next. What do we get? We still have an arithmetic and geometric sequence obtained to form the pattern which is given by these. If this is the case, determine the value of x. If this is the case, determine the value of x. Determine the value of x. So how do we determine the value of x? Right, so we are saying the sum of the Pn from 1 to 21 is this, determine the value of x. All right. So what is this? Well, this means that we have the summation, so it's going to be P1 plus P2 plus P3 plus P4 plus P5. Okay, we can write everything. Right, so we have some of the terms like that. Then we're going to have the other term as well. So this is 5. Before 21, we can have P18, we have P19, we have P20, we have P21 equals 33,5. Okay, that is what you have been given because that is what the sigma notation means. It means you're just adding the terms. So this is the sigma notation. Sigma notation, it means we're just adding the terms like that. Okay. Now we're going to take the odd numbered positions and then the even numbered positions and we add them together. Okay, up to 21. So how many of these would be? So you would take, because these ones, they work together, the P3, the P5, and then you can take 19, 21. Take 19, and then you take 21. So these guys here, we can group them together. And then we have the even ones, which are P2, P4, P6, P18, P20, 33,5. Okay. How many terms are there at this point, for example? How many terms are there at this point, for example? Right, so we start with the ones that are odd numbered, like T1, this one is T2, this one is T3, this one is T4, this one is T5, 1, 2, 3, 4, 5, T6. P1, X, P3, 2X, P5, 3X. Sorry. Now you can see that if it's P1, it's just X. If it's 3, then it's 2. One less. Okay. So it's just X. It increases by 1 the whole time. It increases by 1 the whole time. So if it increases by 1 the whole time, and we have a total of those. So we just have to work out the number of the terms there. Now, if you have 2, 4, 6, 8, and so on up to 20, how many terms are you going to have there, for example? So we evaluate that one. But now we start with the P2 because it's 1 out of 3, P4. So you can use P1 here, you can use P2, you can use P3, you can use P4, you can use P5. So what is P2? P2 is 1 over 3. What is P4? 1 over 9. What is P6? 1 over 27. Okay. 33,5. Yeah, and we remember the two formulas here for the arithmetic. Arithmetic. For arithmetic. We have Sn equals n over 2 into a plus Tn for the geometric. A into 1 minus r to the n divided by 1 minus r, where r is different from 1. Okay, this is what you get. So this is what you get. So now we have this. So x, 2x, 3x, and so on. So if we're to stop at 5, there are going to be how many terms? There are going to be 3 terms here. If you stop at 5, there are going to be 3 terms. If you stop at 3, there are going to be 2 terms. Right. So if you stop at 5, there are going to be exactly 3 terms. If you stop at P6, there are going to be 4 terms. If you stop at P7, there are going to be 5 terms. 5 terms. Right, so the question therefore is, what will the last term be here? What will the last term be? So you can deal with the last term, or you don't even need, but also you just need to know the number of the terms that are involved there. Okay, that are involved. Right, so what will P21 be at this point? What will P21 be at this point? Because you can see that P5 is 3, P3 is 2. Right, and therefore, what will P21 be at this point? So you need to think about that one. Okay, and because you need to know the number of the terms, right? You need to know the number of the terms. Okay, we're going to just have that one. So, but now you need to realize that the terms here will be 11 terms. Right, so if we have a total of 11 terms, we have a total of 11 terms. Right. If you have a total of 11 terms, so what will the last one be? Think about it. Right, so you have a total of 11 terms. So now if you have a total of 3 terms, you have up to 3x. Right, so if you have this one up to 11x, okay, you're gonna actually check that up. Right, you come here, how many terms are gonna be here? They're gonna be 10 terms here. Okay, you don't quite need, but you need to know the number of the terms here, they're 10. Okay. So which means here you can use n of the formulas. N over 2, you can use 2a plus n minus 1 to the common difference. R to the n divided by 1 minus r. Okay, n is 11 out of 2. The first term is x. So you put 11 minus 1. The common difference is like 2x minus x, which is x. The first term is 1/3 in the geometric group of things, the geometric series that is formed by the geometric sequence, because the sequence is simply a list. So you have 1/3 here. So here you have 1 of the 3. Okay, you have 1 out of 3. All right, continue. So this is 1 of 3. 1 minus. What is the common ratio? We got the common ratio to be 1/3. The top is that 1 minus 1/3 equals 33,5. And the result is exactly that one. Let's continue and conclude the calculation right now. What is the final answer to this? Right, so if you do the final answer to this, we get the following. Right, so if you add all these things here, they're gonna be 66x. If you calculate all this, you're gonna get This geometric sum is 0.5. And this is 33.5. So if you solve for x here, it's going to be 66x, which is subtracting 0.5 is going to give us 33. X is 33, you divide by 66, and this is 1 out of 2. Okay. And that is the value of x. Next question. All right, so we're done with that one, and we have that. What is our time there? Our time is 11:24, and I think that it's a good time for us to take a break, and we shall return again in the afternoon. You shall let me know. I'm going to check with you whenever you're free, and then we'll reconnect after 4. Okay, so you'll let me know. It can be 10 at night if you're free at that time, and if you can learn at that time. It's crunch time, so we just do not have time left. But thanks a lot for joining us this morning. I'm going to see you again in the afternoon. Okay.
Okay.
Okay, thanks, Paul. I'll upload the video. Okay.
Okay.
Okay, thank you.